Good morning, everybody, all the listeners. Today we discuss about the fluid and electrolytes balance. Fluid and electrolytes. That means which is the liquid part, and the electrolytes means the minerals, which is very important in our lives. Generally, the six major elements: carbohydrate, fat, protein, minerals, vitamin, and water. These are the six major elements which is required for our maintain our life. So in these cases, the fluid, basically the water, which is water balance in the body is very important. It will be intake, some it will be output. That will balance it. Here it is the imbalance. If it is a imbalance, there is some physiological abnormality which will be occurred. So that's why it will be maintained strictly to fluid or water balance in the body, as well as the electrolytes, that means minerals in the body. Generally, our body is composed by the 60% body is composed of the fluids, and generally the two class of fluids, one is the intracellular space and another extracellular phase. And the intercellular phase, which is called the intercellular fluids, and extracellular fluids, that means they are extracellular phase, that means they are outside the cell. And the distribution of water in the body in the different water compartment depend upon the solute component of each the component. Here the some intercellular fluid which is inside the cell, and extracellular fluid, and some it is called ICF and ISP or interstitial fluid. Intracellular fluid or ICF on the 40% of the body weight, about 24 liters, and interstitial fluid 60% of the body weight, just 9.6 liters, and plasma the 4% of the body weight. It is called, these interstitial fluid and plasma are considered as a extracellular fluids. Osmolarity of the intra and extracellular fluid, it is the same, but if there is a marked difference in the solute content, the always to maintain the intercellular and extracellular fluid must be maintained, otherwise its osmolarity will be changed, and there is some change of the pH, and there is some physiological disorder may come. Next, distribution of the body water. Intravascular, plasma, arteries, vein and capillaries, that is under the class of ECF, extracellular fluids. And interstitial fluid, space between the cell around 1 liter, and transcellular fluid, which is another fluid under the ECF, cerebrospinal fluid, pleural place, synovial places, and peritoneal fluid spaces. Another is intracellular fluid. Generally the potassium is the major elements, and in case of ECF, extracellular fluid, sodium is the major component, and is essential for the normal cell function and provides medium for the metabolic process. Fluid composition varies with the body fat, age, and the gender, that means female or male. 70% body water ECF, and 45% ECF, and ICF 30%. Adult female 50% water ECF 10 to 15%, ICF 40%, and 60% in case of 65% water ECF 25%, ICF 40%. Fat cell contain the little water, and lean tissue in rich in water. It is the more absorbance in this person, and the smaller percentage of the total body water. And human life is susceptible to the saline solution having the salt concentration 0.9%. This is very important. The saline or normal saline, the concentration is the 0.9% W by V, because this concentration is osmolarity with the blood plasma or isotonic with the blood plasma. If we will maintain all these times, otherwise it will be some problem, hypertonic or hypotonic, there is some problems. And body fluids that must maintain the fairly constant with regards to the H2 and specific electrolytes. The primary component of the body fluid is the water. Basically we are taking the water, and water or the body fluids, and women's lower percentage of body water than in the men, and total body water decreases with the age. percent of the water in the human body. In case of fetus, the 100%, and the baby at birth 80%, baby and birth in case of adult 75%, and elderly person only the 50%. That's why in case of elder age person, their skin will be stained due to less amount of body fluid, 20% less. In case of adult 75%, 70%, but in case of elder age 50%, 20% body fluid will be lost. That's why their skin will be loose. How importance in the water? Water provides the medium for the transporting the nutrient to the cell from the cell, and for transporting the substance such as hormones, enzymes, blood, platelets, and red and white blood cells. Water is facilitate the cellular metabolic. All these metabolic function required the waters and proper cellular chemical functioning. And water act as a solvent for the electrolytes and non-electrolytes. It is a good medium for transport of the electrolytes and non-electrolytes. Helps to maintain the normal body temperature. Water also maintain the body temperature. Our normal body temperature is 97 degrees Fahrenheit. That will be maintained by the water. Thus help and facilitate the digestion also. If the high, that's why in case of take some foods, you take some water, that can be helps for the digestion and promote the elimination also. If the proper water will not take, there is a constipation will be problem, constipation will be occurred. That's why the water is the very important person for the help for the digestion as well as the elimination, and acts as a tissue lubricant. Sometimes the tissue lubricant, if the lubrication is not proper, there is a tissue injury will be appear and component in all the body cavities. Water is the principle of the body fluid which is essential for your life. Say that's why the other name of water is called life. Intake and output of water. How to water take and how to eat, and it will be balanced. Otherwise there is a chance of imbalance and there is some problems. And factors dictate the body requirement: amount needed to give a proper osmotic concentration, and amount needed to place water loss excretion. Normal route of water gain and loss. Intake exogenous, that means there's water is coming from the outside. Fluid intake 1.5 liters or 1500 ml from food. Different food stuff also provides the water 700, and endogenous, then this metabolic water, some metabolic reaction 300. Total 2.5 liter water is intake, and output by the skin sensible losses: skin, lungs 850 ml, feces 150 ml, urine 1500, total 250. That's why every day your body will be maintain 2.5 liter intake and 2.5 liter losses. If it will be maintained, there is no problem. Your normal physiology will be occurred. But if it is not maintained, there is a chance of there is some physiological changes. Average intake per day: metabolic water 10%, food 30%, beverage 60%, total 2.5 liters or 2500 ml. And in case of average output per day, 100 to 2000 per day by feces, sweat, insensible losses, skin and lungs and urine. Regulation of this is very important factors. How to regulate the body fluid compartments. There is a basically basic mechanism, you know it, but first one is the diffusion. The molecules from the right, it will increase the concentration. If the diffusion will be increases, then the molecular concentration will be increases and the area of the concentration will be decreases. Another osmotic is the movement of the water through the semi-permeable membrane to higher concentration of the solute. This process can also regulate the body fluid compartments and active transport. This is why the energy will be required. The movement of the substances across the permeable membrane and gradient required for the energy and pump. Another most important factors is the filtration, H2O dissolved substances, and from the area of higher hydrostatic pressure for allow the low hydrostatic pressure. This is a very simple process by which the diffusion, the higher concentration to lower concentration, this is every cell will be occurred, otherwise it will be a problem. Another is the osmotic. Here it is only the difference, higher concentration to lower concentration, but the semi-permeable membrane is required. But in case of cell, the sodium which is outside the cell, extracellular compartment, and the potassium which is inside the cell, and which is done by the sodium potassium ATPase. This intercellular fluid, low concentration sodium and high concentration. The sodium potassium pump, which is ion, and pump out of the cell, potassium ion, and pump out into the cell. The energy to drive the pump and is released by the hydrolysis of ATP. This is called the extracellular fluid with a high concentration of sodium, and intercellular fluid with a low concentration of sodium but high concentration of potassium. This is the compartmental model. Osmotic pump pressure. This is very important. The amount of hydrostatic pressure required for the stop for the flow of rate water osmosis. And osmolarity, it is reflect the concentration of fluid that affects the movements of the water between fluid compartments by osmosis. Osmolarity, number of osmotically active particles present per kilogram of water. And osmolarity, number of osmotically active particles present per liter of water. And electrolytes are the substances, those the molecular dissociated in the ion when placed into the solution. An ion is the atom or groups of atoms with an electrical charge. The normal plasma osmolarity 285 to 292 osmotic per kg, and plasma osmolarity can be measured by the osmometer and identically the concentration of effective osmolarity. And osmolarity 2 sodium plus 2 potassium plus urea glucose molecular concentration. Estimation by double of the serum sodium concentration and clinical use diagnosis of disorders of sodium, water, and electrolytes imbalance by sodium potassium. Osmolarity, the hyperglycemia. Osmolarity increases due to hyperglycemia, that means increased blood sugar, DKA, NAKH, sodium potassium, hypernatremia with water losses, and decreases by the hyponatremia, that means sodium will be losses and water and sodium will be gain and STH. And the difference in the measure the osmolarity and calculated by the osmotic curve is the osmolar graph. Normally numerical similar, increase the osmolarity active substances, ethanol, mannitol, neutral and cationic amino acid. Fractional water content of the plasma reduced, and hyperlipidemia and hyperproteinemia. In healthy state, the osmotic pressure of ECF and mainly to the sodium ion is equal to the osmotic pressure and ICF, which is the predominant due to the potassium ion. The solute and the osmolarity sodium ion, potassium, calcium, magnesium, urea, glucose, and potassium, and it will be given as per the percentage as well as the 80. Sodium is ion, so 92%, 250 in concentration. Sodium concentration 103 milli, associated ion 135. Potassium, calcium, magnesium, urea, glucose. The tonicity, which is the most important factor, the measure the transport of the water across the biological system causing the changes in the cell volume, tonicity or isotonicity. The red, in case of red blood cell, in the hypertonic solution, the red blood cell will be shrinkage. There is no problem. It will be a temporary damage, or it is called the granulation. If the water will become there with the original forms, but in case of hypotonic, isotonic, the normal cell behave the normal. But in case of hypotonic, there is a introduce the water and soiling of the cell. Ultimately, the cell will be burst, or it is called the hemolysis, and it is a permanent damage of the cell. This isotonic amount of water transport into the cell equal to the amount of water the transported out from the cell. The amount of water which is incorporated in the cell and which is generally 0.9% normal saline solute concentration inside the cell equal to the concentration of the cell. Red blood cell in the hypotonic solution, that will be burst, and 0.45% NS concentration less than concentration in the plasma, and H2 is the in vivo for hemolysis. This is the hypertonic and the hypertonic solution. We can see it. Always it will be maintained. Electrolytes. So thank you all the listeners for listen this electrolytes balance, water balance. It is very important for our life. Thank you all.